This video is about nonlinear systems of equations. And so you probably have come across linear systems of equations in intermediate algebra, some pre-algebra courses. They look like this, just as a reminder. This is linear systems. And remember, linear means line, so you might have something like this. 3x minus 2y is 7. And then another equation, 4x plus 8y is 15. These are both equations of lines, and the fact that there's two equations makes it a system. The fact that the highest power of any variable is 1 makes it a linear system. And so graphically, you could graph this first line and maybe it looks like that, and you could graph this second line and maybe it looks like that. And if the lines intersect, that place of intersection is going to be the solution. So if they intersect, this would have one solution, this whatever this x and y value are. The second thing that can happen when you're solving a system of equations like this is you could graph the first line and you could graph the second line, and if the lines are parallel, you will see that those don't look parallel. If they're parallel, then they have the same slope and those lines will never intersect, and this is where you get no solution. So algebraically what will happen is you'll get something that makes no sense, like 0 is equal to a number, which is not true. You'll get some untruth. The third thing that can happen is you could graph the first line and then you could graph the second line, and the second line could lie right on top of the first line. And so you ask yourself, where are they intersecting? And they're intersecting at every single place. And in this scenario, this is where you get infinite solutions. And so when you're solving algebraically, this is called the dependent system, and you'll get something like the truth, like 0 equals to 0, but you don't get x is equal to a number and y is equal to a number. So you might recall that. We're going to be looking today at nonlinear systems of equations, which means one of the equations will not be a line, which makes a lot of sense because we've been studying conic sections. So let's have a look at the first one on our sheet, which is this one. And it is 3x squared plus 2y squared is 8. Oh, I have something different on your sheet. So let's see. Let me erase this. The first one you have is x squared. Oh, well, I have the wrong thing up here. Let's do this. 3x squared plus 2y squared is 8. 3x squared plus 2y squared is 8. And then we have x minus y is equal to -2. All right, this is the first system. So when I look at this is the equation of an ellipse. I'm learning to recognize what these are equations of, and that's the equation of an ellipse. And this is a linear equation. So we have, let's just imagine what are the possibilities that could happen here. We have some kind of ellipse, okay? Ellipse and a line. We could have an ellipse and the line, and they completely miss each other. The ellipse lies completely above or below the line, and in that case there'd be no solution. No solution here, all right? Or you could have an ellipse and you could have the line that cut through it. You could get, in this case, two solutions. Or you could have an ellipse of some sort and you could have a line that just touched it at one place, just tangent, and you could get one solution. These are the possibilities of the things that could happen with this particular scenario. So we're about to solve it algebraically and see what does happen. So when I have something like this, when you have systems of equations, lots of times it's nice to be able to add the equations together to get one of your variables to add to 0, and then you can just solve for the one that's left. But in this case, we're not dealing with like terms. If I add 3x squared plus x, nothing's going to sum to 0. I'm just going to have 3x squared plus x. They don't even add together. They don't combine because they're not like terms. So in this case, I'm going to use substitution. I'll pick an equation, and I'm going to pick the second equation. I'll solve for either x or for y. So I'm choosing to solve for x because it looks easy to do. So to solve for x here, what I'm going to do is say I'm going to add y to both sides. X is equal to y minus 2. Now I'm going to use substitution method where I substitute in y minus 2 for the x in the first equation. So that's going to look like this. 3 times, instead of putting x, I'm going to substitute in y minus 2. Y minus 2, and then plus 2y squared is 8. And I'm going to solve this equation for y and see what happens. So when I square y minus 2, I get y squared minus 4y plus 4 plus 2y squared is 8. So I'm going to distribute the 3. 3y squared minus 12y plus 12 plus 2y squared is 8. This I recognize as a quadratic equation. The highest power is 2, so I'm going to collect like terms. 3y squared plus 2y squared is 5y squared minus 12y. And then I have a 12, and I'm going to subtract 8. So 12 minus 8 is 4, and then I have a 0 on one side. You can solve this using the quadratic formula, completing the square, possibly factoring. I think factoring might work. I'm going to factor this. 5y times y is 5y squared. Let's see, how about minus 2 and minus 2? Let's see. 5y squared minus 2y minus 10y is negative 12y. Negative 2 times negative 2 is positive 4. And now I would just set each one of these equal to 0. 5y is equal to 2. Y is 2 over 5. Y minus 2 equals 0. Y is equal to 2. So this will be true when y is 2 and y is 2/5. So let's figure out the x values that go with that. Right here, x is equal to y minus 2. So for 2/5, that's going to be 2/5 minus 2 when I substitute in the y. That's 2 over 1. So x is 2 over 5 minus 10 over 5 when I get a common denominator of 5. 2 minus 10 is negative 8 over 5. So this one goes with this one, and that is one point that these curves intersect at when x is negative 5/8 and when y is 2/5. All right, let's plug in y equals to 2. All right, y equals to 2. If I substitute that in here for x, x is equal to y minus 2 or 2 minus 2, which is 0. So here's my second point. When x is 0, y is 2. So this is the scenario where we have an ellipse and the line passes through it at 2 places, and these are the 2 points at which it will intersect. Okay, let's look at the second one. So on your sheet, I have this one, x squared plus 2y squared. I have something different, so let me erase this. Although that's similar. I have x squared plus 2y squared is 9. X squared plus 2y squared is equal to 9. And then I have 3x squared minus 4y squared is 27. Okay, let's consider these two curves. The top one is an ellipse, and the second equation is the equation of a hyperbola. So let's just, what in the world could happen here? Let's see, you could have an ellipse, and you could have a hyperbola. For instance, it could hit 4 places, 4 solutions. You could have an ellipse, and you could have a hyperbola that hit right there, tangent, 2 places. You could have a hyperbola and ellipse that hit 3 places. You could have it hit tangent there and hit right there. You could have an ellipse, and so this was 3 solutions. You could have it have 1 solution. Let's see. You could have an ellipse that was just tangent on one of the sides that just hit 1 place, 1 solution. You could have an ellipse and a hyperbola that totally missed each other, and this would be 0 solutions. So there are lots of different scenarios that could happen here. We're going to figure out what's going on here. Doing some algebra. Now this is a situation where our terms are like terms and we could add some stuff together that would help something cancel out. So right here, I have x squareds and y squareds. So if I want to try to eliminate a variable, this is called elimination method. I'm looking at the y squareds. If I took the top equation and I multiplied it by 2, then I'd have 2x squared plus 4y squared is equal to 18. And then I could add this plus 4y squared plus negative 4y squared, we get 0. And that's going to be helpful. So I'm going to do that. Let's just see what happens when I do that. Did I write this down right? X squared plus 2y squared is 9. 3x squared minus 4y squared is 27. Okay, so let's see. I'm going to multiply the top equation by 2, by positive 2. Okay, what happens there? Then this becomes 2x squared plus 4y squared is equal to 18. And I'm going to add these together. Okay, 3x squared plus 2x squared is going to be a 5x squared. Negative 4y squared plus 4y squared is 0. And then 27 plus 18, let me make sure, 27 plus 18 gives me 45. Nice. Then I'm going to divide both sides by 5 and get x squared is equal to 9. I'm going to take the square root of both sides and I'll get x is equal to plus or minus the square root of 9 or plus or minus 3. I get two x answers here. One is x is equal to 3 and one is x is equal to negative 3. Okay. Now, let's figure out what our y values could possibly be. Well, when x is 3, plug it into either one of these equations. I'll just choose the top. So, 3 squared plus 2y squared is 9. Okay, let's see what we get here. And then in a minute, I'm going to do it for negative 3. So what happens when x is negative 3? We would say, okay, negative 3 squared plus 2y squared is 9. What answers do we get there? So 3 times 3 is 9 plus 2y squared is, I want to just stick with purple. Okay. 3 squared is 9 plus 2y squared is 9. Subtract 9 from both sides and you get 2y squared is 0. Divide by 2, you get y squared is 0. Take the square root of both sides. So y is equal to plus or minus the square root of 0. But 0 doesn't hold a sign. It's not positive, it's not negative. It's just in the middle. It's neutral. So we just get y equals to 0. What solutions did this one yield? It told us that when x is 3, y is 0. This is one of the solutions. Okay, over here, when x is negative 3. Negative 3 squared is 9. Okay. 9 plus 2y squared is 9. Subtract 9 from both sides, we get 2y squared is 0. Divide by 2, we get y squared is 0. Take the square root of both sides. 0 doesn't hold a sign, so we're just going to get y is 0. So this tells us that when x is negative 3, y is 0. So this gave us two solutions. I did sort of sketch this when I was doing this problem. And so what I think's happening here is we have a hyperbola and we have an ellipse, and our ellipse is in the middle and it's touching right here and it's touching right there. And those are its solutions for that one. Okay, let us look at the next one. Number 3 gives us this. 2x squared plus 3y squared is 5. Okay, and so that one is an ellipse and a hyperbola. Another situation with an ellipse and a hyperbola. So let's see what's happening there. Right here. 2x squared plus 3y squared is 5. And 3x squared minus 4y squared is negative 1. Okay. Now, let me just take a minute and say, this is a hyperbola. And the fact that it equals -1 is not that big a deal. Let me just make this be okay for you. If you were to multiply both sides by -1, you get -3x squared plus 4y squared is 1. And then if you switched positions of these two, you could write this like 4y squared minus 3x squared is 1. And when there's that negative, who's leading is the y. And so this just means this is a hyperbola facing up and down. So don't let that -1 bother you. You can multiply both sides by a negative, and it's going to be a positive number over there. It's not a big deal. All right, so anyway, let's just proceed with what they've given us. So if we want to try to cancel something out, I'm just going to deal with the y's because I have this nice positive negative thing going on. So if I multiply the top equation by 4, I could get a 12 right there in front of the x squared. And if I multiply the bottom equation by 3, I could get a -12 y squared, and those will add to 0 very nicely. So that's my plan. You don't have to do it this way. There's other ways you could do it, but this is just what I see going on. I'm going to go to get rid of my y's. I'm going to multiply the top equation by 4. I'm going to multiply my bottom equation by 3. And so what that gives me is I will get 12 x squared plus 12, no, sorry, 4 times 2 is not 12. 4 times 2 is 8x squared plus 12y squared is 20. Because I multiply 4 just in case anybody's, you multiply 4 on both sides of the equation, you multiply 3 on both sides of the equation to keep it balanced, right? So then this becomes 8x squared plus 12y squared is 20, and then down here we get 9x squared minus 12y squared is -3. So we'll add 8 plus 9 is a 17x squared. This plus this is 0. 20 minus 3 is 17. So we get x squared is equal to 1 when we divide both sides by 17 and take the square root of both sides. We get x is plus or minus 1. X is equal to plus or minus the square root of 1, which is plus or minus 1. So let's do this. When x is 1, what happens? When x is -1, what happens? Plug it into either equation. I'll just choose the top equation and work with it. So in the top, when x is 1, I'll have 2 times 1 squared plus 3y squared is equal to 5. Okay, so I get 1 squared is 1, 2 times 1 is 2, plus 3y squared is 5. Subtract 2 from both sides, we get 3y squared is 3. Divide by 3, we get y squared is 1. Take the square root, we get y is plus or minus 1. We get 2 answers from this one. We get when x is 1, y is 1. And when x is 1, y is -1. Okay, let's deal with when x is -1. Again, I'm going to choose the top equation, 2 times -1 squared when I substitute in my x value, plus 3 y squared is equal to 5. Okay, -1 times -1 is 1, times 2 is 2, plus 3y squared is 5. Subtract 2 from both sides. Divide by 3. Take the square root. And so this also yields 2 answers. This tells us when x is -1, y is 1, and when x is -1, y is -1. There are 4 points. We get a solution at 1, 1, 1, -1, -1, 1, -1, -1. And so what is happening here is we have some ellipse that's passing through these points, and we have some hyperbola, and it's hitting 4 times. Okay, the last one on our sheet goes like this. We're going to solve, this is number 4, 2x squared plus 3y squared is 5. 4x squared plus 6y squared is 8. Let us try to solve this. I'm going to use elimination. I'm going to multiply one of the equations by a number to try to get something to add to 0. So when I look at this, I see the x's. Let me go for those to try to eliminate them. I'll multiply the top equation by -2 on both sides. And what that gives me is a -4x squared minus 6y squared is equal to -10. So let's add these. 4 plus negative 4 is 0. Okay. 6 minus 6y squared is 0. 8 plus negative 10 is negative 2, and I get 0 as negative 2, and that's not the truth. And so what that's telling me is that there's no solution here. There's no place where these two graphs intersect. There's no solution. So if we wanted to try to imagine what might be happening here, I did a sketch of this just to get an idea, and this is what I think is going on. One of the ellipses is bigger than the other ellipse. Maybe it goes out to here. And the other one is completely inside the other one. And so there's no places where they're intersecting. So that's what's going on in that particular system.